Hello students, we continue with the next part of the lesson, that is scattering of light. Okay, let's see what is scattering of light. In last year you must have studied scattering of light, Tyndall effect, colloidal solutions and all. Yes, so this is the same thing. The interplay of light with objects around us gave rise to several spectacular phenomena in nature. A blue color of sky, color of water in deep sea, the reddishness of sun at sunrise and sunset are some of the wonderful phenomena we are familiar with. In this particular class, in the previous class, you have learned about the scattering of light by colloidal particles. You remember that the beam of light passes through it and you can see the particles. The path of the beam of light passing through a true solution is not visible. Then when it is visible, when it passes through a colloidal solution. However, its path becomes visible through a colloidal solution where the size of particles is relatively large. Now what is scattering of light? Actually, when light passes through a solution like this, there are so many particles inside. So every beam of light, it colloids with each and every particle in the solution and it reflects in all the possible directions. So this is called as scattering of light. Okay, now Tyndall effect also you have studied last year. The Earth atmosphere is a heterogenic mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust and molecules of air. All this is included in the air. When a beam of light strikes such fine particles, the path of beam becomes visible. Why? Because here so many particles are there, and when every particle collides with them, then it scatters the light, and this path becomes visible. The phenomena of scattering of light by colloidal particles give rise to Tyndall effect, which you have studied in class 9 also. This phenomena is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. You must have seen that. So when a small hole is there and light enters from that small hole, how we see the path of light is visible over there. The scattering of light makes the particles visible. Tyndall effect can also be observed when sunlight passes through a colony of dense forest. Here, tiny water droplets in the mist scatter light. Okay, when there is a dense forest and from some hole of the forest, you can see the light entering in. Then that time also you can see the scattering of light. The color of scattered light depends on size of the scattering particles. What does the color depend on? It depends on the size of particles. Very fine particles scatter mainly blue light, while particles of large size scatter light of larger wavelength. Okay, all right. So if they are large size, they have different wavelengths. If the size of scattering particles is large enough, then the scattered light may even appear white. Okay. Why is this color of the sky blue? You have seen the sky, it appears to be blue. Have you ever wondered why is this color blue? So, if you see the sky, you see a blue color like this. But if you go up in space, will you see this blue color? No, you won't see this blue color because sky is actually not blue in color. The thing is, it scatters blue color the most. That is why the sky appears to be blue. Let us see the reason for why the color of the clear sky blue. The molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. Okay, now see children, these molecules in air, whatever are the small molecules which are present in the air and other fine particles which are present in the atmosphere, their size is very small. Okay, they are very small in size and therefore the wavelength uh, this size is smaller than the wavelength of light. Wavelength means speed. Last year in physics, you must have studied the term wavelength. Wavelength there denoted by the letter lambda. So this wavelength is larger than their size, or so you can say the size of these particles is smaller than the wavelength. These are more effective in scattering light of short wavelength at the blue end than light of larger wavelength at the red end. Okay, now you know in the Vibgyor colors, blue is also one of the colors. So we know that this spectrum, if you remember, every light bends according to its color. Like red bends the least, if you have seen my previous video, and violet bends the most. So in between somewhere there blue color is there. So whatever is the wavelength of blue color, no, that that helps in getting this blue color of the sky. Okay, the red light has wavelength about 1.8 times greater than blue light. Means the speed of red light is more, 1.8 times than the blue light. Thus, when sunlight passes through the atmosphere, the fine particles in air scatter blue color more strongly than red. Understood? So, how in rainbow we are able to see all colors, but in this particular thing, when we are looking at the sky here, out of Vibgyor, violet, indigo, blue, green, red, yellow. Okay, the blue color is scattered more because it has shorter wavelength than red. That is why the sky appears to be blue to us. So the scattered blue light enters our eye. If the earth had no atmosphere, there would have been no would not have been any scattering. Now why we see it blue? Because there is atmosphere present and every time that refraction is taking place. But if this atmosphere was not there, then we would have not seen the blue color of the sky. Then the sky would have looked dark. The sky appears dark to passengers flying at very high altitude as scattering is not prominent at such heights. Okay, for passengers who are traveling in the air, for them this color is not visible. Okay, so they will see the sky dark in color. You might have observed that danger signal lights are red in color, isn't it? Danger means whenever we want to show, or even we see signals. In signal, red light means stop, green means move. Why? Red means stop. Now, can red has longer wavelength. Wavelength means it can travel longer distances. So red is put over there. Even you see in the railways, they have signals which are red in colors, and when they want to give the signal that the train can go, they show a red color cloth. Okay, this is the reason why red is used. Okay, so do you know why? That is, red is least scattered by fog or smoke. It does not get scattered. Means red color will not get scattered. It has a larger wavelength. It can travel longer distances. Therefore, it can be seen in the same color at a distance. Okay, this is an activity given in your textbook. What is the activity here? That the rays of the light are passing. They are allowed to pass through this solution. In this solution, it is sulfur is present in this solution, and then afterwards we see the beam of light passing. Just quickly we will see the activity. Okay, before that we will quickly just discuss what is this activity. On the left hand side here, S stands for source. A strong source of light is kept, and then here a circular hole from which the light can pass through. Initially there is a clean water in this, and afterwards we put little sulfuric acid, and we also put sodium thiosulfate. Okay, so that also we put in this, and we allow the light rays to pass through this. Again, we have one cardboard sheet over here. Okay, and in this there is again a circular hole, and again later on there is a circular hole, and then here is a screen on which you can see the image. So what do we observe? Let us see. You will find fine microscopic sulfur particles precipitate in about 2 to 3 minutes, because sulfur, we have first wood sulfur thiosulfate, sodium thiosulfate and sulfuric acid. So they will react with one another and precipitate will be formed. Precipitate means something left over will be formed. So that leftover you will see in this. Then as the sulfur particles begin to form, you can observe the blue light from the three sides of glass tank. So you will see blue light here. This is due to scattering of short wavelength by minute colloidal sulfur particles. So this light is getting scattered inside by those sulfur particles. Observe the color of the transmitted light from the fourth side of glass tank facing the circular hole. Okay, so you can observe it from the other side. It is interesting to observe at first the orange red color and then bright crimson red color on the screen. Here on the screen you will see these changes in colors. This activity demonstrates the scattering of light that help you to understand the bluish color of sky and reddish appearance of the sun at the sunrise and sunset. So this is what somewhat will help you how we can, you must have seen the sun's color in the evening or in the morning. It looks little reddish in color. So this will help us to understand why does it look little reddish in color. So color of the sun at sunrise and sunset. Okay, you see I have shown a picture over here. This is, I think you can call it as sunset, you can call it as sunrise. You can see the color of the sky over here. Okay, what is the reason for this? Let's see. Light from the sun near the horizon passes through thicker layer. Now near the horizon means here, this is our horizon. It is thick layer because see here this much, see if this blue color if you see is the atmosphere. Okay, so here if you see, if the observer is standing here, it has to look through a lot of distance through the atmosphere, whereas here this distance from the atmosphere to the observer is shorter. Okay, here it is covering more distance. So the light from the sun near the horizon passes through thicker layer of air and larger distance in the Earth's atmosphere before reaching our eyes. So this distance is larger. So when sunlight enters here, it has to cover larger atmospheric distance. Whereas when the sun is here, it has to cover less distance. However, the light from the sun overhead would travel relatively shorter distance. At noon, means in the afternoon, the sun appears white as only a little of the blue and violet colors are scattered. Okay, then near the horizon, most of the blue light and shorter wavelengths are scattered away by the particles. So blue light goes because it has shorter wavelength and it cannot pass through longer distances. So it will go away. So near the horizon, most this we have seen. Therefore, the light that reaches our eyes is of larger wavelength. So from here, whatever light is reaching our eye is of larger wavelength, and you know who is having larger wavelength. Mostly red color, orange color are having larger wavelength. This gives rise to reddish appearance of the sun. That is why when the sun is here near the horizon, the sun sets, we see reddish or orangish in color, whereas here when it is at the horizon, we see it bluish or violetish in color. Okay. Now these are some of the questions which are there in the textbook. We have also discussed this in my slides. Why do stars twinkle? And explain why planets do not twinkle. Okay. Then why does the sun appears reddish early in the morning? Just now we discussed. And why does the sun appear dark instead of blue to the astronauts? Because up there is no atmosphere, so the light will not scatter. Okay, apart from this, children, now all the questions which I have given answers, only those questions are there. All the other questions are deleted from the syllabus. So only these questions you will write, and that is why I am giving you these extra questions also. So first is draw neat and label diagram of dispersion of light through a glass prism. So you remember that prism diagram, okay? Incident ray, refracted ray, angle of deviation, angle of reflection, all that. That one diagram you draw. Then explain Newton's experiment of recombination of glass prism with the help of neat and label diagram. So recombination, one he kept straight and the other he kept inverted, and from one he saw that one white light getting converted into a spectrum, and in the second he saw that a spectrum getting converted into white light. So that experiment you have to write, explain and draw diagram and define the term spectrum and dispersion of light. So complete this in your classwork.